Okay, so getting back into where we were, we're looking at the limit as x goes to, we should have done this as a -2 from the right, and then this stuff does make sense. So -3, -3.4, -3.9, -3.99, -3.999. Now, if you, these are approaching -4 and these are approaching -2 from the right. And if you were to plug in -2 here, you would have -2 minus 2, which would be -4. And that is the value of the limit. So this equals -4. And then this next one, we have, again, a rational function, x minus 3 over x squared minus 2x minus 3. So looking at a table, and I'll show you how to do this algebraically in a minute, but looking at a table here, when we plug in 4, 3.6, 3.1, 3.01, 3.001, so these are approaching 3 from the right. And when we plug in values, those values, we get 0.2, 0.22, 0.24, 0.249, 0.2499. So these are approaching 0.25, which is equal to 1/4. And how you would get that algebraically is to simplify. So x minus 3, this is x minus 3, x plus 1. These cancel, and then you can use direct substitution, which I'll talk about in a minute. This would be equal to the limit as x goes to 3 from the right. Sorry, this is so tiny, 1 over x plus 1. Then you would plug in 3 and get 1/4. Again, I will talk you through that in a minute, but I want you to see it there with that problem. All right, so number 5, this is a polynomial, so we can just plug in and go. This won't have any issues anywhere. All of these have potential issues because of the bottom not wanting to divide by 0. So this one, we don't have that issue. So we can just plug in. So this would be equal to 1 minus 6 times 3, which would be 1 minus 18, so -17. Same thing on this one, it's a polynomial, so just plug and go. So we have 4 squared minus 4 plus 3. So 16 minus 4 plus 3. So 16 minus 1 is 15. Oh, that should be a -4, my bad. That's why my answer doesn't match the answer I have here. We're approaching -4, so we're looking at -4 squared minus -4 plus 3. So 16 plus 4 plus 3 is 23. -4 squared gives you positive 16, and then this minus turns into a plus sign. All right, so tables, use Desmos to do the tables, or your graphing calculator. Desmos is easier. And then just, so again, you type it in as f of x equals the function, and then hit that wrench. It's not the wrench, but the a gear. And then once you hit that gear, you hit the table button and go from there. And then just type in all the values for x that you want. To do this graphically, I've sort of shown you that a little bit, but let's do it in some more detail. So this first part for A, we're looking at the left-hand limit, the right-hand limit, the limit, and then the function value as x goes to -2. So find -2. Here's when x equals -2. The left-hand limit, get on the left side of -2 and approach -2. The y value we are approaching is -1. For the right-hand limit, as x goes to -2, get on the right-hand side of -2, move toward x equals -2. What y value are we approaching? That is -2. The limit as x goes to -2 does not exist. And that is because -1 doesn't equal -2. You can think about it. I like to talk about this like my fingers. If I was dragging my fingers along this graph from the left and the right-hand sides, when I get to -2, do my fingers touch? In this case, no, there's this vertical gap, so the limit does not exist. The function value when x equals 2 is the only time we care what's happening at the point that is -2. All right. Let's see here. Now let's look at 3. So 3 from the left, 3 from the right, 3 from both sides, and then the function value at 3. In this case, they're all the same. From the left, we're approaching the y value of 0. From the right, we're approaching the y value of 0. Our fingers would touch at 0. So that is the limit value of the limit. And this function doesn't have any holes or anything. And it is just through there. So the value of the function is also 0. All right, next up, we are looking at 0 from the left, from the right, all together, and the function value. From the left, we are approaching -1. From the right, we are also approaching -1. Our fingers would touch there, so that is the value of the two-sided limit. F of 0, however, is undefined because of that open hole. That doesn't affect the value of the limit, but it does affect the function value. All right, and then last but not least, let's look at 1. I'm going to get some of this stuff out of here. So approaching 1. From the left, we're down here, when y is 0. From the right, we're approaching the y value of 2. So the limit does not exist because 0 doesn't equal 2, or the left-hand limit doesn't equal the right-hand limit. The function value here, you're looking for the filled in part, which is when y is 0. Okay, so the graph above is a piecewise function. Each piece is part of a polynomial. Polynomials are nice functions, and the limit as x goes to a of p of x is p of a. So you would just look at the piece where you are and plug it in. Now, if it's undefined, obviously that doesn't work. So anyway, okay. So we can do piecewise functions analytically then, or algebraically, like using arithmetic instead of looking at the graph. So if we're trying to figure out the limit as x goes to 4 from the left, we would pick the piece, right? So pick the piece. There we go. Pick the right piece and plug in. So when we plug in for the limit as x goes to 4 from the left, we would plug in to the part where x is less than or equal to 4. Sorry, I don't know what that is. And so this would be 1/2 times 4, which would be 2, which is what we got up above when we did that. If we want to look at the right-hand limit, you're going to look at, this would be the right-hand side because it's bigger than 4. So you would just plug in to that piece. So this would be 4 minus 1, which is 3, which is what we got up above. Okay, so similarly, we can do this with this one we haven't actually looked at the graph for. So the limit as x goes to 2 from the left, oh my goodness, of f of x. We want to look at 2 from the left. So which of these would be approaching 2 from the smaller side? It would be this one. So we're going to plug in there. So 2 squared minus 1, 4 minus 1, which is 3. And then the limit as x goes to 2 from the right of f of x, that would be this piece here in the middle. So there's nothing to plug into, so it's just 3. So there, the limit as x goes to 2 does exist, and it is 3. That means where those pieces, they overlap there. X minus x squared minus 1, so something like this, and then this like this. Like since it's a parabola into a flat line there, but the limit is 3. Okay, I am going to stop there for now, and I will do another video with the indeterminate forms. Sorry this is so long. I was trying to make this quick, but there's a lot of stuff here. I will be back I will do another video with indeterminate forms in a little bit.